you will see that I have some fancy new tools to use. I'm still figuring out how to screen record. So this is a way of me doing it a little bit better without you guys seeing like the behind the scenes stuff. So this is only going to be like the PowerPoint. You're not going to see me clicking on the pens and whatnot. But now I have this cool little laser pointer. So today we're going to finish up acid bases. This is it. After this lecture or after this lesson, this is it for acids and bases. Monday, again, it's going to be a castle learning. It's not a quiz. It's not going to be graded, right? Remember, it's just for me to see if we can move on. Instead of starting a new topic, what we're going to do instead is review. So starting on Tuesday, we're going to be doing review material of old units, just because we haven't really seen them in a while, just in case the Regents is still going on. I don't really know what's going on with that yet. I want to start reviewing. But today, we're going to swing our lesson back around to this demo that we started with, right? The milk of magnesia that turned from that bluish color to the reddish color. We're going to see why indeed that happened. So as you listen to this PowerPoint, please fill in the notes. We'll do some practice problems together. And then on your own, I have a different worksheet that is posted on iTunes U that you can work on. So how can indicators, we know that when we used in this demo was a universal indicator, how can different indicators be used to tell us the pH range of a substance? So first we have to define indicator. So an indicator is a substance used to determine the pH range or value of a solution. Really, it just tells us you are below this pH, you are above this pH, or you're somewhere in between. And what's cool is that indicators are actually special compounds that change color based on the pH. So again, what we saw in that demo was universal indicator. It changes color based on the pH. And we saw a whole rainbow of colors, which each relates to a very specific pH. And this topic is very, very, very simple because we have all the information we need on table M. So you'll see we have a list of indicators. It gives us a pH range, and then it gives us a color change. I'm going to go into more specifics about it in about a minute, but pretty much the first number relates to the first color. So this range is 3.1 to 4.4, meaning if we are at a pH of 3.1, we're red. If we're at a pH of 4.4, we're yellow. Well, what happens if we're above or below those numbers? Anywhere below 3.1, we're going to be red. And anywhere above 4.4, we're going to be yellow. Anywhere in between, you're kind of a mix of colors, which you can see here. So that's this methyl orange, right? Anywhere below 3.1, we are red. Anywhere above 4.4, and we are yellow. Anywhere in between, you're this orange color. And each indicator, this directly relates to table M, has a different range. So phenolphthalein, for instance, from 0 to 8.2, we are clear. You don't see anything. Between 8.2 and about 10, you're this light pink color. And then above 10, you're this dark pink color. So each range that it gives us on table M relates to like the lower limit and the higher limit. So if we had to write this down, when the pH is below the range, the indicator is the first color listed, right? Methyl orange, if you're below that 3.1, you're this red color. If you are above the range, it will be the second color. Again, if you're above 4.4, you're this yellow color. If you're above 7.6 for bromothymol blue, you're blue. If you're above 9 for phenolphthalein, you're pink. And again, in the range, you're kind of a mix of both of these colors. Very, 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 very easy. You just have to know that it's anything above the high end of the range and anything below the low end. So again, below the range, you're the first color listed. Above the range, you're the second color. In the range, you're kind of this weird mix. All right, let's practice this. Practice problem 1. What color will phenolphthalein be in a solution with a pH of 7? So we're going to go to table M, right, our common acid-base indicators. go to phenolphthalein, and the first thing we have to do is look at the range. So we are in the range of 8 to 9, but we have a pH of 7, which means we're below this 8. If we are below this 8, we're going to be the color that's first in the list, which is colorless. So we are below 8 because we're at a pH of 7. We are colorless. Easy. This question is a little different because it's asking what is a possible pH for a solution which turns methyl orange red. So if we look, methyl orange is going to be red. Since red is the first color, it's anything below this first pH range, which means it's anything below 3.1. Because 3.1 is the first pH listed, and red is the first color. And we're looking for when it's going to be red, which means we're below this pH. Similarly, what is the possible pH or pH range of solution that turns thymol blue green? Well, let's go to thymol blue. Well, we have yellow and blue, not green. Well, think back to like elementary school art class. What colors make green? Yellow and blue. So if we're green, we're somewhere between 8 and 9.6. Makes sense? We're not yellow, we're not blue, we're somewhere in between. We're in between 8 and 9.6. And finally, what color will phenolphthalein be with a pH of 13? Well, let's go back to phenolphthalein. The range, again, is 8 to 9, so we're above this 9, which means we're going to be the second color, which is pink. So again, you're just using the numbers and the colors with the different indicators. The first number relates to the first color, the second number relates to the second color. Very simple. There's one more practice problem that we're going to do. Which solution has a pH that changes thymol blue indicator yellow and bromothymol blue indicator blue? So it gets a little confusing, so stick with me. Let's check out this first indicator first, thymol blue. So it's saying that thymol blue is going to turn yellow. Well, thymol blue is going to be yellow anywhere under 8. Under 8. Bromothymol blue wants to be blue. So bromothymol blue is going to be blue above 7.6. So in reality, we're looking for something that's going to be above 7.6 and under 8.0. So if we go through our choices, 3.2, is that between? Nope. 7.8, yes it is. Let's check the rest of them though. C, 9.6, that's above the 8, so that's not good. And 5.4 is below the 7.6, so that's not good. So our answer is B. 7.8. So again, we just looked at each individual indicator and saw when they would be the color listed, and it has to be somewhere in between those two. Because bromothymol blue is going to be yellow under 8, and then thymol blue, even I got confused. Thymol blue is going to be yellow under 8. Bromothymol blue is going to be blue above 7.6. So let's swing this back to our demo that we started with, right? This was the milk of magnesia, the universal indicator, and me adding hydrochloric acid. So what was happening initially? Initially, we had milk of magnesia, universal indicator, and water. This blue color tells us that we're at a pH range of above about 9, right? A little bit lower than 9. What happened when I added HCl and acid, our pH went down, right? We went to this reddish color, which indicates a pH of 4, but as a lot of you guys noticed, the color would go back from this reddish color to this bluish color, which means in reality, what was going on? Well, our acidity, or our pH, was returning from our 4 to our 9. And let me give you a little brief explanation of how that was happening. So milk of magnesia is not very soluble in water. It doesn't really dissolve that well in water. So a little bit dissolved in the water reacted with the HCl, turned it acidic, and then over time, since that reaction happened, you lost the milk of magnesia, so more milk of magnesia would dissolve in the solution, returning it back to that blue color. So it was a cycle because that milk of magnesia in here was being dissolved, returning you back here. I added more HCl, returned it back here, more dissolved, went to this color. Eventually, what would happen if we kept adding HCl though? All of that milk of magnesia would react and it would stay this reddish color. So this starting demonstration that we did for the whole unit relates directly to indicators, acid, bases, pH. It kind of wraps up everything we've talked about. In reality, in this solution, if we were to zoom in on a microscopic level, we would see more OH minus than H plus. If we zoomed in here, we would see more H plus than OH minus, right? Because the lower your pH, the more H plus ions. Actually, let me write that in for you. The more H plus, the higher the pH, the more OH minus. So this relates everything we've talked about. So try those practice problems out on your own. Again, just use Table M. It's all related to Table M. And if you have any questions, feel free to shoot me a remind, comment, email me. You guys know the drill. All right. Have a great weekend, and I will talk to you guys next